I've called this part 1 of how to use Excel for Insights because I suspect that we will need some more sections to go into more depth. So here's the agenda. I'm going to start off with some real basics about Excel, probably too basic for most of you, but then we'll build the complexity up from there, looking at how we use survey data with Excel, pivot tables, going to look at some visualization, and then very briefly add using automation through macros. And then we'll have the Q&A. As we get to each of these tools, I've actually made mini recordings to try to reduce the amount of errors and typos that I put into the process and to try to get it all to run to length. So the very basics, I'm going to introduce a little bit of data. I'm going to show how we enter formulas, how we use functions, how we can do some editing. I'm using a Mac. So when I want to do some of the keyboard shortcuts, I press the Command key. Those of you on PCs, you will typically want to press the Control key as a bit of a switchover. So let's go to the first of these little videos. So I've got some data here that shows the revenue and the costs for 4 regions for a company, and I can calculate the gross profit. Always we type in an equal sign when we want to make it a function. So it's the revenue minus the cost is going to give us the profit. I'm going to fill that down, and now I've got it for all of the regions. Similarly, I can calculate the margin. So I would go, it's the gross profit divided by the revenue. This time I'm just going to click on that cell, double click, and it fills down to there. We didn't want it in that cell. Now I want to add the total information. I could go equals sum of these cells here. Quite often I will type it in, but I can also just go up to the auto sum, and it works out that I want the sum function. I want it for that range. I'll fill that right. And now I want to know what is the overall gross margin, and I can fill down that formula. And I'm going to tell it that I want that to be bold. And that's a nice, simple introduction to this process. So those were relative references. What we're going to look at now are absolute references and a very simple what-if model. So let's make this simple model slightly more complicated, and we're going to use absolute references. So if I want to calculate what the revenue is, this time I'm going to multiply the sales by the price. But I can't just hit return because that's a relative reference. And if I want to fill down, it will keep changing and it will go wrong. So what I can do is I can put $1 in front of the B and $1 in front of the 2. And that becomes an absolute reference. And then I could fill that down. And we've got the values that we want there. There's another way of getting at that absolute reference. So let's look at the costs. It's the sales multiplied by the cost. But this time I'm just going to hold down the Command key and T. And that will automatically give me the absolute reference. And again, we'll just fill that down. And then we can do as we did before. The gross profit is going to be equal to the revenue minus the cost. The gross margin is going to be the gross profit divided by the revenue. And we've got all of those there. And that is the sum. So we will just fill that right for these cells, and for the gross margin we are going to fill that down, tell it that we want to be bold. So we've used absolute references, and now we can fill down and we can fill right in the way that we want to. This is also a very simple what-if model because we can see that the gross margin is 67%. But if we could reduce the price of these items to $1.50, then in fact we'd have a gross margin of 75%. Just setting that back to $2. If we increase the price to $6.50, then we'd have a gross margin of 69%. So all of a sudden, we have a very simple what-if model that allows us to look at scenarios. And the final bit of basics is going to be using absolute references in a slightly more complex way and introducing conditional formatting. And in this final basics example, we're going to look at some more use of absolute references and also conditional formatting. So here's a matrix of data which is quite typical to the research industry. It's the percentage of people who are saying that these brands are sexy or they're cheap or stylish. So I want to see if there's a better way of making some of that data stand out. So what I'm going to do is I'm going to put a column in here for the total, and I'm going to put a row in here for the total. And I simply want to sum everything in there. So I click on there and I can fill that right. Command R. And I'm going to again click on auto sum, and this time it knows to look at the row, and it does that. And then I'm going to fill that all the way down. And if I look at the data, I can see that there's quite a range of differences in those numbers. So what I'm going to do is I'm going to select these cells here and just look at conditional formatting using the color scheme. And what we can see is that brand 4 scores much more highly on most attributes. And if we look at the numbers, 97, 94, 97, 98, and then a couple of no numbers. So it's got most of the good values. And we see that brand 7 has very few of the good values. It has much lower scores across the board. So what would be a good score for brand 7 and what would be a not such a good score for brand 7? We can make that stand out by using a chi-squared trick of subtracting the expected values from the observed values to create a standout matrix. So the first thing I want to do is I want to make a matrix that's the right shape. So what I do to make my life easier for typing is I simply copy the shape of the matrix. I'll blank these cells. And then I'm going to put in the expected values. And the expected values are gained by multiplying the row total by the column total and dividing that by the grand total. But we need to use absolute references because when I fill down and fill right, we want to keep referring to the column totals, we want to keep referring to the row totals. So if we take this cell here and I hold down Command T or Control T if you're using a PC, it gives me the absolute reference. Now for the row, I always want it to be row 10. So I'm going to put the dollar in there, and I always want it to be column H. So I'll put a dollar in there. And now we can hit return and we get 54%. We can fill that down. And we can drag that right. And these are the expected values. So now I want to produce the standouts. Observed minus the expected. And let's just tell it that we do not want that cell to wrap. So we'll bring up the formatting and just say don't wrap that text. So that will come through quite nicely like that. We'll take this matrix, we know what size it's supposed to be. We'll pop it in just here. And we'll clear out these values. It is the observed value minus the expected value. And we can fill that down and we can fill that right. So what we can now see, if we take brand 7, which had very low scores before, we can put in the conditional formatting. And now we can see that although the scores for this one tend to be lower, it's actually really cheap, really friendly, and it's much less sexy stylish. So that's some of the basic functions into play. Now I'm going to start looking at survey data and some of the things that we might want to do with it. So here is some data that looks more like market research data. There's only 20 respondents, and that's how it fits on the screen. All the same principles would work with 100, 1,000, 10,000 participants in the data set. So we've got a variable over there called gender, and people have answered it with an M or an F. Very often, we want the data to be noughts and ones so that we can put it through all sorts of processes. We often find it difficult to work with letters. So one of the things I'm going to do is I'm going to recode that gender. I don't want to edit the original data. That's a very unsafe practice. So I'm adding columns which are the recodes of the data. And I'm going to use an if statement. So equals if the gender cell equals an F, comma, then it's a 1. Else, comma, it's a 0. And I'm going to fill that down. And now we've got a recoded version of that variable, and I can audit that if I want to. So we can then summarize that data. So we could say equals sum of this range here. And I'm going to tell it that I want to use the range 2 to 21. So Command T, just as good practiced within that. Now, in terms of the total, what I'm going to do is go here, and I'm going to say equals count of these here. And there are 20 values, 10 of them are female, so I can just go equals the total minus the number that are female on this occasion. And we can put in the percent data by saying equals female divided by the total. And I absolutely do want to use absolute references for those, so Command T. And let's tell it that we want that to be a percentage. And we can fill that down. So now we've recoded a variable, we've got noughts and ones, and we've got some summaries of that information. I'm going to do almost the opposite thing now. I'm going to code the NPS score into letters. I'm going to code it into the range N for neutral, P for promoter, D for detractor. I'm going to recode the NPS using an if statement. Equals if the NPS value is greater than 8, then we know that it's a promoter. So we'll put a P in, comma, and then we put another if statement inside that if statement, equals if this value is less than 7, then it's going to be a detractor. We'll put a D in. And if it's not a promoter or a detractor, it's going to be a neutral. Put an N in. And then I'll close the second if statement, and I'll close the first if statement. And so that is a promoter. And we're going to just fill that down. And now we've got a mixture of promoters, neutrals, detractors. So I'm going to use count if. So equals count if, open bracket, the range that I'm going to count. And I'm going to make that an absolute reference so that I can move it about. And I'm only going to count them if they are a P for promoter. I'm going to fill that down to the next two cells, and because I've used absolute references, it gives me the same answer. But I'll just go into this one and change the P to a D, and I'll go into this one, I'll change the P to an N. And now, to get the sum, I simply need to add together the promoters, detractors, and neutrals. That gives me the total. That, of course, allows me to do the percentages divided by the 20, and that's another absolute reference. And we'll put that in percentage format. We can fill that down. And now we can put in the NPS score, which is equal to the promoters minus the detractors. So let's describe the data using some more functions. Look at producing a few statistics directly from this sort of typical market research survey data. So we're going to produce, first of all, the mean. So I'll go to the bottom of the age column. I'm going to click auto sum, but I don't actually want it to sum these numbers. I want it to give me the average, because in Excel speak, the mean is called the average. And I want this to refer to 2 to 21. I'm going to use absolute values for the top and bottom. So I will be able to fill this down, and I'll be able to fill it right in ways that make sense. So now we've got the mean. And what I'm going to do is I'm going to fill it down all of these cells. And then I'm going to go here and double click and change the word average to median. And I'm going to double click here. And I'm going to change it to the standard deviation. And I'm going to choose the sample standard deviation. It doesn't make a lot of difference. And you can look up what is the difference between the population standard deviation and so on. Go here and change the word average to max, and we're going to go here and change the word average to min. So now we've got the mean, median, standard deviation, max and min. One of the reasons that I would always recommend looking at the mean and the median is when they are different, they're often telling you something useful. So let's fill this across on the other data where it looks applicable. And on this data here, I'm actually going to change the formatting of the number slightly, because I'm going to put commas in, because I find it makes the thousands easier for me to see. So we will go to number, and we will use the thousand separator as a comma, no decimal places. There. And so we can see there is a really big difference between the mean, 37,000, and the median. The middle person earns 31,000. The mean is 37. If I use conditional formatting to have a look at the data, what we can see is there is one value, 110,000, that is way, way above all the others. There are 5 values that are around 20,000. Those are in the bright red. So that is why there is a difference between the mean and median. And every time in your data that you see a difference between the mean and the median, you need to investigate so you understand why that difference is there and decide whether or not the mean is actually a useful measure that you're looking at. Now we could keep using those type of functions, but actually pivot tables will often do the job better for us. Look at the pivot table. So we've got our survey data here, and I'm just going to select it, and I'm going to go to data, summarize with pivot table, and it says, is that the right range? Yes. And we're going to do it on a new worksheet. This is quite often the best way to do it. And I'll just make that sheet a little bit bigger for you so you can read it a bit more easily. And what I'm going to start with is I'm going to look at some of the data in the context of gender. and I actually want gender to be in the columns. And I'm going to look at that first of all against age. And that gives me the sum of age, which is not what I want. So I right click to get the field setting, and I tell it that I want the average. So now what I can see is that the people who are identified as female have got 39.3 as their average age, and the people identified as male 44.4. So amongst these 20 people, the average age of the men is higher. So let's put income in there as well, and I'm going to tell it that I want it to be averages. And I'm going to drag this value down into the rows, because what I want is for each one of these to come one under another. So we can see here that the women have got slightly higher income, 38,000, plays 36,000. If we add in the bank NPS, again we go to field settings and we tell it that we want to use the average. And we go to how happy are they with life, and we want to use the average, field settings, average, and just to make things tidy, we will bring gender down into the values and we'll have the count. So what we have there is, I suppose it's like it's a nice little tally of the data. We've got some averages, and at the bottom we've got the sum, so we can see what's going on in the data. Of course, instead of having male female across the top, we could have had member non-member, we could have had the 5 categories of happiness. But what I'm going to look at next is looking at the interaction between the NPS scores, the 3 types, the promoter, detractor, neutral, and gender. So let's get rid of all of these that we have at the moment. And we're going to bring down this other type of NPS that we had, and we're also going to put it in the row column. So what we can now see is that there were 7 detractors in total. There were 5 people who were neutral. There were 8 who were promoters, because that's from that recoded data that we did. We can also look at the pattern in terms of female and male, and we can see there's a much bigger number. This is really easy to compare because they're both 10. If it had been 30 and 20 or 50 and 30, harder to do in your head. So we can bring in the same data again. So I select this new version, I go to field settings, and I want to summarize it by show data as calculation, percentage of the column total. Okay, so it's got more decimal places than I'd really like, so I would normally shrink those back. So let's just do that. And there are different ways of tidying that up. But that'll do for the moment. So what we now have is a column for the grand total. So in total, 40% were promoters, 25% were neutral, 35% were detractors. But we can also see those percentages for female and male. So maybe if we center that data as well, we can just make it easier to read. And when we've got what we want, we will copy these and paste them elsewhere, because pivot tables are very dynamic. You don't want to leave too much information in them because it changes. So changing gear, let's have a look at how visualizing can help us understand. And we're going to start with that same survey data. We're going to look at how visualizing using charts in Excel can help you see a pattern that isn't so obvious with statistics. So what we have here is the survey data we looked at before, and I've put in the correlation with age and income and the bank NPS with how happy people were. And I then squared that to get the R squared, because we're obviously much more interested. I'll just double click on this here, and what you can see is there's a nice function in Excel to do correlations. It's just Coral, open the bracket, the first section of data, and then the thing you want to correlate it with. And I've used those absolute references for the happy column so that I can fill right and I can get the correlations with other columns as well. So it suggests, if we look at these R squared, that there is very little relationship between age and how happy people are, and there's zero relationship between income and how happy people are. But we could just investigate that with a chart to make sure there really is no relationship. So I'm going to insert an XY plot. And let's just make it a little bit bigger for the moment. Well, it does look as though there is some sort of pattern, because we've got age along the bottom and we've got levels of happiness going up the page. So what I'm going to do is I'm just going to click on one of those. I'm going to add a trend line. Well, let's also display the R squared. I'll make that a little bit bigger so you have some chance of reading it. Okay, so there's almost no correlation between a straight line through those data points and the data points. But if we select this line here and we tell it that we want to have a polynomial, what we now have is an R squared of about 60%. That's really quite high. And what that is showing is that younger people tend to be quite happy, people in the middle are less happy, and older people are happy. Now, this is synthetic data, but actually that is a pattern that you will see in the real world if you look at data. And there isn't a correlation because it's not a linear function. Polynomial highlights it nicely. So let's look at a different sort of data and using it in a slightly different way. In this example, again, we're going to look at how we can use Excel charts to help us find patterns, to visualize things, to see things. So what I've got here is some data that I've downloaded from the Worldometer site on the 10th of September, and it's the number of cases and the number of deaths from COVID since the beginning of the pandemic for the 16 countries with the highest number of deaths globally. And because we've downloaded from the website, they've come down alphabetically, and I've also downloaded the overall data for the world. So let's explore this data, and I'm going to select the countries, and holding down the command key, I'm going to select the deaths and cases per 1 million of population. And I'm going to ask Excel to chart those as a column chart. And we can see a problem pretty well straight away. Let's make it bigger so that you can see it. And let's make the fonts a little bit bigger so you can see the labeling. Because they are very different scales, it's hard to see the deaths. And I want to look at the pattern. So what I'm going to do is two changes. The first is I'm going to change this to be a combo chart, which has got lines and bars. We still have the problem that it's hard to see the deaths. So I'm going to take those lines, I'm going to format that data series, and I'm going to put it on the second axis. Now it's a lot easier to see. The left-hand axis is for the blue data, for the deaths per 1 million. The line chart in orange is cases per 1 million. Visually, they're now adjusted, and I've got the scales on the side. I'm going to do a couple more things to make this data a bit easier to see. I'm going to take this data cell here, which is the world, and I'm going to change the colouring of that cell to be read, because I want to remind myself that that isn't a country, that is the world. It's the reference point against which we're looking at everything else. This data in the chart is linked to this data over here. So if I go over to the original data and we go to sort, and I sort it by deaths per 1 million of population, largest value to smallest. Now we start to have something that's a lot easier to interpret because we have some overall pattern. And one of the things we notice is that there are a group of countries that have much higher number of cases than deaths in terms of the ratio. So Italy, UK, Spain, France, Germany all have more cases in relation to the number of deaths than do Brazil, Poland, Colombia, Russia, Mexico. So we can see there's a bit of a pattern going on there, and we might think that there are perhaps at least two explanations. Maybe the health services were much better in the countries like Italy, UK, France, Germany, Spain, and they were able to help more cases, or there was more testing going on and more official recording of testing, because of course you don't know how many cases you have unless you have testing. So when we start to look at the data in this way, we can start to explore different ideas and follow them through. And finally, we're going to have a very quick look at automating tasks. Now let's have a look at automating tasks, and I'm going to look at a simple recorded macro. So imagine that we get a data sheet like this every week or every month, and one of the things we need to do is we need to add some recoded data that's going to tell us whether the NPS score is a promoter, a neutral, or detractor. So what I'm going to do is I'm going to turn on the macro, record new macro. And this is going to be create NPS. And it's going to store it in this workbook. We might put a description down here. Macro to define N. In fact, we're going to go promoter, detractor, neutral. So it's now recording the keystrokes I make. So I can go here and say that I want these to be promoters, I want these to be detractors, and I want these to be neutrals. And I'm going to put them in that blue that I use to highlight. These are things at work. I'll put a grid on it. And then for promoters, I'm going to say equals if the net promoter score is greater than 8, then it's a 1, else it's a 0. For the detractors, I'm going to say if the net promoter score was less than 7, then it's a 1, else it's a 0. And the reason I've done them in this order is I can say equals if this cell plus this cell equals 0, then it's a neutral, else it's not. And I'm going to put those into my blue, and I'm going to put those together, center them. And I'm going to stop recording at that point. I'm going to explain why when I use it as a macro in a moment. So stop recording. And that macro now exists. So let's just remove the information that we've got. Imagine this was a new spreadsheet which had come in. I can go to the macro. It's going to show me the list of macros, so I'm going to run that macro. And now I can fill that down. And why that's useful is that the next month when the data comes in, maybe it's not going to have as many cases. So again, I'm going to run the macro. It gives me the top cell, and then I can just fill it down for all the other cells. So by creating the macro just to give me the columns, the heading, and the first row of the data, it doesn't matter to me how many rows there is in the next week's data or the next month's data. It does matter that the NPS is always going to be in column F, and it does matter that I can write information into column H. So if the format of the data changes, then I would have to go in and make a new macro, or I could edit the macro. So as I mentioned, edit the macro. That brings us to Visual Basic for applications and the final example. In this recording, we're going to look at a slightly more advanced use of macros. So in Excel, there is VBA, Visual Basic for applications, which you can write and make commands. And I'll show you the command that I wrote for this simple example in a moment. And you'll be able to access it from the slides and try a similar thing yourself. And if we have a look here at the verbatims in column H, we've got people typing in various brands of bank. But some people have typed NA, some have typed non, some have typed NA in lowercase. And it'd be nice to clean all of those out before we start looking at what we've got. So we can do that with a macro. It will automatically look and see how many rows there are in the data, and it will then work its way through and clean them up for us. So I've written the macro, so I'll show it you running, and then we'll have a look at the code itself. I go to macros. So we've got that create the NPS we showed you before, which was a simple record macro, but this one is one that I've written. We're going to ask it to run. And there we are. It's produced a copy of the existing data, except where it's some form of non or NA, in which case it's created a blank for us. It could have created a standard code. It could have created them all as NA. It could have created them all as non. We control what that is going to be. Now, I'm not going to spend any time digging into the code. You will be able to download the slides from this presentation, and then you can type the code in yourself if you wanted to. So we have a subroutine. The first thing we do is we declare all of the variables we're going to use. I've put in comments, so you'll be able to work out what all those variables do. The next thing we do is we define the codes that we want to set to blank. So I want to set the NAs to blank, and I want to set the nons to blank. You'll notice they're in uppercase because I've made life simpler for myself. I've not had to write everything in uppercase, lowercase, mixed case, and so on. We have to tell the program where is it going to read the comments from. They're going to read them from column 8. Where do we want the new ones to be written? They're going to be written in column 9. The next line finds out how many rows there are in the data. So that's why it will always deal with the right number of cells for us. It then creates the heading, and then we get into the meat of the progress. So it's called a for loop for every single row in the data, starting at row 2, because row 1 is only the heading. We read the verbatim, we trim it, which means we take the space off the front and the back if there were any spaces. We turn it into uppercase, which is how we can work with a very simpler way of doing it. And we set the flag to say, this is not an NA. And then for each of the codes we're checking for, and in that case, in this particular case, it's just 2 of them. Is it NA? Is it non? If it is either of those, then we're going to set the flag to say this is an NA. And we then decide what we're going to output. We will either output NA because the flag has been set, or we will output the original verbatim that we were reading in the first place. And that is how that works. So I look forward to your questions.